We're going to take the decimals. We're going to change them to percents. Okay. Seriously, focus on this. This is out of all of the stuff that you are responsible for tomorrow's quiz. This is the stuff that I want to make sure that you get into your heads because it's going to take a little bit of time. All right, 0.05 is what percentage? This is kind of the reason why we did this in the warm-up. Kat, what do you got?
5%.
You may go get. At random, I will just choose people. It won't be everybody, but every now and then, as long as you participate, you can grab something out of the drawer. 0.20, Hergs.
20%.
Good job. You may go get. What about 0.375? Phil.
37.5.
Yup. What about 0.225? It's going to be random. Joe.
22.5.
Say it again, bud.
22.5.
22.5% correct. All right. 0.10. So,
10%.
correct. You may go get.
What?
Capiz.
5%?
And it's a repeat, yes.
Oh my god!
Okay, great.
I don't get it.
Nah, sit.
Oh.
Sorry. Maybe next time. Okay. So, even though this question's being asked on the next page, let's just do it because it's in front of us. When you take all of your decimal equivalents or your relative frequency and add it up, what should it add up to? 10. Not the percent. You would be right for the percent. That was going to be my next question. But what about the decimal equivalent? You got it, 1.00, and you may go get for that. Okay. That's kind of being asked on the next page, but it's in front of us, and you'll see a lot of this lesson 5, you got to flip back and forth, and it's kind of a headache, so we'll tackle the questions as long as the data is right in front of us. Okay, on to the next page. This is the one that we did. The relative frequency column all adds up to 1 or 1.00. Which interval, and you got to flip back again, which interval has the greatest relative frequency and what's the value? Hunter.
450 through 570.
Yeah, to make it easier, what head size or hat size is that?
Wait, the medium.
Yes, it's the medium hat size. And what was the value for it?
0.375.
Which is what percent?
37.5%.
Yes. Great. What percent of the head circumferences should be between 530 and 589? So again, you got to flip back. 530 to 589. So everything under 590. So now you got to add up. A couple ways you could do it. You could add up your percentages. Well, the other way you could do it is you can add up your frequencies and see what that is when you divide by 40. You can do it that way too. Alex, what do you got? It winds up being exactly 80%. Good. Do you see how it's 80?
No.
All right, well, watch what I did.
No.
I took those three intervals starting at 530 to 590. If you add up these three percentages, it'll add up to 80%. I want you to ask questions. That's good. If you're not seeing it, please be active and raise your hand, and we'll go over it. Okay, Jack. You may. Okay, let's go forward. Let's move forward to this. I'm going to ask you to go back into lesson 4 and find the histogram on head circumference.
I remember that.
Okay, it's there. I want you to go back and find it because we're going to compare it, because the only difference now between that histogram and this new one is that the new one is showing relative frequency for each interval, not actual counts. Go back to lesson 4. If somebody can get a page number, that would be great. Page 6, lesson 4. What do you notice? Really take a look at, I'll keep this one up here for lesson 5. You are responsible for looking at the one on your page for lesson 4. And what do you notice? Hunter.
Like you said, the frequencies are different and it's basically the same thing.
What's basically the same thing?
The size of the graphs. Like,
Okay, the size of the bars.
on the bottom numbers are the same.
The intervals are definitely the same. Ben?
On lesson 4, the frequency is whole numbers. No.
Okay, do you see that that's the only difference? In lesson 4, these are the actual counts, the whole number counts. In the lesson 5, this is the relative frequency. Everything else is identical. Not only just the shape, because it is definitely symmetrical, but the actual sizes of the bars are exactly the same. Because if you take a look at your first bar, even though here on lesson 5 it's 0.05, the only difference is in lesson 4 is you have a 2 here, right? It counts by 2s. Does it count by 2s?
Yeah.
Okay. Here, I have a 0.20 on yours. That should be 0.6. I'm sorry, 8. What?
When you change that to
I lost you.
why are you pushing
The bars are exactly the same. Instead of this being an 8 on yours, it's a 0.2 when you do it as relative frequency. Then you have 12. Is it 12? Then
what?
it should be 12 as your bar. Okay, 15? 15? All right. Then, what do you got? 8 again?
It's 9.
Oh my God. 9 should be a little higher than the 8. It's the 9. Then what? I'm afraid to ask.
4.
And 2.
3.
Virgo, you're killing me. Killing me, Smalls. All right, so back to the point. The bars are exactly the same. The shape is exactly the same. Only difference is instead of the frequency numbers being the whole numbers, in lesson 5 it's the relative frequency. You wind up getting the same thing. All right, let's move forward. How do you describe the shape? This is all new for you. I know.
Symmetrical.
It is symmetrical. Agreed. It could be slightly skewed right, but honestly, symmetrical is the better answer. And with B, as we've already talked about because it was right in front of us, both histograms are exactly the same. What about part C? Isabel said that most of the hats that needed to be ordered were small, medium, and large. Is that right?
Exactly the same center of data.
What?
What have you been doing the last 24 hours?
What have you been on?
Kid usually says nothing in the morning all of a sudden.
No, he's pretty quietly.
I don't know what he's on. I gotta hit pause. We'll be back after this commercial message. All right, part C. Are most of the hats that need to be ordered small, medium, or large? Small, medium, and large. It's not an or question. Is she right by making that assumption that most of the hats fall in that range? And if it helps, if you want, go back to the original table because the histogram themselves don't actually have the hat sizes by label. Alex?
Yes.
Okay, agreed. It is definitely right. What percent is it? Al, what percent is it?
Is 80%.
Yep, 80%. Go get Al. Is the second one for you? Yeah, hold off.
I have it. 10.
Stop.
Not very good.
On your tinkleberry.
Okay. The one that I definitely need to get through with you today is this one. Okay, because you'll see, you'll see in a minute, but what I want you to do first is add up all of your frequency numbers and tell me what you get. Dylan, what do you got? If you add correctly, you get 29. What makes this difficult is that when you do your relative frequencies with a denominator of 29, 2 out of 29, when you do it, if you do it with long division, is going to give you a big, long number. And so we are going to use a calculator for this. But first, before we do that, 1 out of what?
29.
What we do have us helping out is that when you hit 5 out of 29, the rest of them are already ones that we will have already done. So really, the first 4, 1, 2, 3, 4 values that we can get, that we're going to use a calculator for, once we get it, there's repeats. But first, complete all of the division or fractions. The next thing I'm going to ask, well, we're going to use a calculator. But what we're going to do is we have to round this to the nearest hundredth. Luke, you already have a calculator. Just help us out. 2 divided by 29. Give me the whole entire number. And I'm going to ask you not to write this down just yet, everybody.
0.06896.
A little bit slower, bud. 0.0.
0.68965.
Okay. I'm going to round that to the nearest hundredth. So underline. I'm going to don't write this down just yet. I'm going to underline the hundredth. Sorry, that's my thousandth. And I'm going to look to the neighbor. Does it round up to 0.07 or does it stay at 0.06? Kurt. 2. And that's what I'm going to ask you to write down, 0.07. Which is what percent? Tyler.
7%.
Correct. All right, Kurt. Luke, 1 divided by 29, please. Again, don't write it. It's going to be long.
0. I mean, no.
0.0.
0.0.
Yeah.
344,827.
All right, what does that round to? 5 or more, raise a score. 4 or less, let it rest. 0.03. That you can write down. 0.03. Luke, 6 divided by 29, please. Go. Thank you. 6 divided by 29, my friend.
0.206.
Hold off. 0.206.
8.
That's all I really need. That's all I really need. I've got all the figures I need to round up or down. What does that round to? Zode. You may go get. Point what? Ooh, be careful now.
Wait, can I get it? Oh.
I need another significant figure. Take it. Second shot. You're allowed. 0.21. Go get. 0.21 is the one we're going to put down, which is what percent, Zode? Very nice. One more other unique value we have to get, and the rest are all repeats. Luke, 5 divided by 29, please. Random.
0.1724.
Rounds to what? Kurt.
0.17.
I agree. Which is what percent?
17%.
Go get. Everything else is repeats. So we have another 0.17 and another 17%. Same thing here. 2/29 we did was our very first one, 0.07. 2 divided by 29, again, 0.07. And 1/29 was 0.03 for 3%. I have a question for you. Will it add up to 100%? Why not? But he's right. If you round, maybe you get lucky and it rounds up to 100%, but it may not. In theory, it's supposed to add up to 100%. But because you're round, you might be a little bit off. Doesn't mean that the figures or the percents are wrong. What should all your decimals add up to? What should they add up to? Phil? It may or may not, depending on how we round. Chances are, probably doesn't. Okay, so now, honestly, you got to take one more other little leap, and that is deciding how you're going to lay out these numbers on your frequency table. Because if you count wrong, you're not going to have room. So if you go to this, well, the intervals are easy. That's the easy part. What's that first seating capacity? What was it? 17K. I'm going to put. We could cheat a little bit. So let's take care of the easy stuff first. To less than 17.5? Yes? Okay. Less than 18. Follow suit with me here because then we'll tackle the hard part together. 18.5. 19. And I'm writing too big already. If you did it right, you wind up second to last line at 22,000. Notice I did the little less than sign. Is it? Did I mess up somewhere?
No, you just forgot the last number.
Okay, so I'll include it. Okay, those are my intervals. What you have to decide is what are you counting by going up? Take a look at your high and take a look at your low. Give me a value you want to start at, but I'm gonna have you not write it down yet because we got to make sure it fits before we start nailing it down. What do you think? 0.03. All right, hold off. Let's see if it works. 0.03. Then what? Okay. Then what?
0.09.
Okay. Then what?
0.012. Wait, no, 0.0. No.
Point.
0.12
0.12. Go ahead.
and 0.15.
And then?
0.18.
Does it make it? No. What's our highest value? 0.21. It's not enough. Can't do it by 0.3 or 0.03. What's the next logical choice? We can go a little less. Yeah, 0.05 is a good fit. So let's do it. It's okay to have a little bit more room. That's fine. You just definitely don't want to shortchange yourself. Did I do it right?
Yeah.
Okay. 0.05, 0.10, 0.15, 0.20, 0.25, 0.30. All right, who wants to come up and put the first line where it should go? I don't even really care about the bar right now. Put the line and we'll take care of the bars later. Jack Choice. What's the value? What's the value for the first interval? What's the value for the first interval? What are you going to plot? What's the number that you have to plot? I was going to flip 0.07. Okay, come on up. I was trying to avoid so I don't have to flip back and forth. I'm going to ask you what is the value because I don't have it in front of me. Agreed. Yes. A little bit less than halfway between 0.05 and 0.10. Go get. Don't worry about coloring. Okay. In fact, don't even worry about the bar. Just put the line where it goes. We'll take care of all the vertical lines later. Phil, you want to come up and do the next one? What's the value, bud? Go for it. 0.03. If you want, choose a different color. Looks good. Go get. Next one. What's the value, T-Rex? 0.21. Come on up. Choose a different color. Good. Go get it. Dill's next one. I think this is the last, Dylan, last unique, come on up. Last unique value, I believe. The rest are all repeats, and I'll take it from there. Good. Good. Go get it. Yes. All right, the rest are repeats. Another 0.17, right? And then another one? Then what?
0.0. 0.7.
Oh, wait.
0.7?
0.07.
0.07?
And then 0.07 again.
Then 0, 0.
And then
0.3? 0.03?
0.03.
Okay, that's it. Finish up your histogram, and then I'll tell you what your homework is. There it is.
Thank you.
Or how you describe the shape. Ferg, I'm going to you.
What?
What's the shape?
Right.
Say it again?
Right.
Skewed right, I agree.
That's what it means.
We've been doing this for.
No, but
That's okay. For part E, I think it's easy to go back to the table. Seating capacity between 18.5 and 19, everything up to, but not including 20,000. I think it's easier to go back to this. 18.5 starts here, and so we're looking at adding up 3 interval percentages. If you can't do it in your head, do it on paper, because you got to add, or do 17 times 3. And again, remember, it's rounded, so it's approximately code.
0.51.
Which is what percent? Because I think they're asking percent.
51.
I agree, 51%. Go get code. And then point F, without having you go back into lesson 4 again, I'll just help you out. So it's determined whether you're doing relative frequency or actual frequency. Your histograms are identical. They're going to look exactly the same. My cousin Vinny. Okay? All right, I'm going to write, you got this, because I'm going to go back to the homework page and tell you what you got to do tonight. I'm not giving you a full problem set. It's a lot. So write this down so you know what to do, and I'm going to tell you whether you can use calculators or not. And I would like you to start it now. You have about 4 minutes. Hold on, let me look, because I got to remember. Okay, that's a good suggestion. You can do pages 8 and 9, no calculators. Because you'll see it's out of 25 when you get to page 9, and that is very doable. I honestly don't, because it's going to take more time for you to get into your groups. By the time you sit down, I'm going to tell you to put your seats back again. There's no time. Sit and go, but nobody else sit. Go.